All right, Honor Chem kids, we are now going to talk a little bit about doing some calculations with kinetic energy and heat. And one of the things that I do want to remind you is that often for thermodynamics, a lot of the work we are going to be doing in temperature is in Celsius, but sometimes there may be a problem or two that is in Kelvin. So this is a super important thing for you guys to make sure you're being careful with your units, and know that if you do have something that's asking for Kelvin, I'm just putting the equation here that you learned in the gas laws, how to convert between Kelvin and Celsius again. So the first equation that we're going to talk about is what we call energy of motion, or calculating the amount of heat. And heat is defined as the amount of kinetic energy. So when you think of kinetic energy, you're thinking about molecules in motion, and that is equal to heat at constant pressure, which most of the lab experiments that we do, we would be under a constant atmospheric pressure. So we can say that the kinetic energy is equal to the heat, or we can represent that heat. Remember, we can represent that as Q. And this Q equation is known as Q is equal to the mass times the specific heat times the delta T. And the specific heat is defined as the energy needed to heat 1 gram of substance 1 degree C. It is a physical property of substances, just like a substance would have a melting point and a boiling point. So too does substances have what we call a specific heat. And again, that's just the amount of energy needed to heat 1 gram of that substance 1 degree C. I think you've seen from the earlier video that I had you watch that not all substances have the same specific heat. Here is another form of the equation, and this is the one that actually we use more. It's what we call the MCAT equation, because this looks like an M and a C, and then the delta, meaning change in temperature, kind of looks like an A. So often in honors chemistry classes, college chemistry classes, we call this the MCAT equation. Again, where now you should be kind of recognizing the symbol for specific heat is C. Don't get that confused with degrees C, which is in Celsius. So sometimes that gets confused for kids. And you'll notice that the unit is joules per gram degree C. So that equals out to be the unit. And again, it's important when you're doing this work to follow your units. Okay, so how would we recognize that we are working with kinetic energy words or kinetic energy problems? And it basically is in the words. So if you hear words like heating or warming or cooling, don't those just sound like there's a delta T, that you're going from one temperature to another? So that's how you're going to recognize that that is a Q equation problem. The other thing before we do a Q equation problem, I just want to kind of remind you that you could be in different units of energy, and this would be something good to write down in your notes. 1 calorie is equal to 4.18 joules of energy. And if we were multiplying this by 1,000 and this by 1,000, we would have 1,000 calories and 4,180 joules. Well, we could call that a kilojoule, and we can say that 1 kilocalorie is equal to 4.18 kilojoules, because all I would do in that case is divide both sides by 1,000, and you'd get the same thing. But what I want to remind you guys is, like, how would we do this if I asked you how many calories are in like 15.7 joules? So if we take a look at this problem, we could write here what we're starting with, which is 15.7 joules. And then I can do my little ratio here, my equivalence, and let's see, that means I have to have joules on the bottom, so I'm going to put 4.18 joules on the bottom, and I'm going to put 1 calorie on top, and you'll notice that you get something like 3.76 calories. So that's how you can just use dimensional analysis to convert from joules to calories, or calories to joules, or whatever. This is a more interesting problem. This is kind of like what calculating with that MCAT equation is going to look like. So It's asking you to calculate the amount of energy released. Now, when you hear the word energy, I want you to think of a unit. What would be a unit of energy? Either joules or calories. So that's kind of what you're looking for. So what would be the amount of energy in joules released when you have 32 grams of liquid ethanol and that cools 5 degrees C? So there's a couple things going on here. The first thing that I want you to notice is that you should turn to page 2 of your packet of information that you downloaded in this lesson. This is the thermodynamics data. And notice that the thermodynamic data has a unit here, or has a thing here that says kinetic energy. So that means you're going to be calculating with your Q equation. And this is a table of specific heats. We've got some compounds here, and then we've got a specific heat. And notice that we have a specific heat that's different for each compound. So acetone specific heat is different than water specific heat. And also between the two, the specific heat of acetic acid and a liquid phase is different than the specific heat of acetic acid in a gas phase. So that's also interesting and unique. And then here I've got some more formulas and I've got some more specific heats. Notice that I've got ice, which is solid water, this specific heat here. So you might see some of that on the worksheet. Notice also the unit for specific heat is in joules per gram degree C. So what I'm going to do now is I'm going to show you how I would solve this problem using this information. And you should be looking at your page 2 that you have for the specific heats. So I'm going to use my equation here, which is the Q equation. So let me turn my pen on here. And so I'm going to write out Q is equal to the mass times the specific heat times the delta T. Now I'm just going to plug in what I know. Well, I know that the mass is 32 degrees or 32 grams, and I know that I'm talking about liquid ethanol. So I look at liquid ethanol here, and I notice that that has a specific heat of 2.44, and that's joules per gram degree C. So I'm going to multiply that. That's my C. And here, my delta T was already given for me. It's saying it's cooling. So that means it went from a higher temperature to a lower temperature, and that change in temperature was 5 degrees. Okay, so I'm going to put 5 degrees here. Notice that degrees C cancels. The grams are going to cancel. And when I solve for this, I get something like 390.4, but since I have 3 sig figs, 390 joules. So that's how much energy is released when 32 grams of liquid ethanol cools. Okay? You might also see a problem that looks like this. A chemistry student finds a rock, which he thinks is gold. He weighs the rock and finds that it has a mass of 14.3 grams. He heats the rock from 25 degrees to 52 degrees upon the absorption of 174 joules of heat. Find the specific heat capacity of the rock to determine if it's gold. Okay, so, all right, well, I can do that. I'm going to use my Q equation. And so here's my equation, and you know my mantra, show the equation, show the substitution. So here's the equation, and now I'm going to just substitute what I know. I know that this is 174 joules. I know that my mass is 14.3 grams. C is what I'm actually going to solve for, so I'm going to put the C there. And then the delta T would be the change of 52 minus 25, which happens to be 27 degrees C. So now, when I solve for this, it's going to be 174 joules in the numerator, and in the denominator, I have 14.3 grams, and I'm going to have 27 degrees C. Do you notice the unit that I'm going to have now? That's a unit for specific heat. And when I solve this, C will actually be 0.451 joules per gram degree C. So that's a 5. So let me just kind of make that a little bit longer. So the answer is 0.451 joules per gram degree C. So now when I look at, is this really gold? I would look up in a table, what is the specific heat? Let me get rid of this one here for a minute. What is the specific heat? I would look up in a table what the specific heat of gold is, and you'll notice here the specific heat for gold was 0.129 joule per gram degree C, roughly. So this isn't gold. Unfortunately, the student didn't find gold. He found something else. So those are examples on how you do some calculations with the Q equation, or what we call the MCAT equation. So good luck and continue on with your learning.